Hi everyone, in this presentation I'll explore what whale songs can tell us about the seafloor. To start it off, as I'm sure many of us already know, the ocean covers over 70% of the planet, yet functionally we have only mapped 10% of it at this time. This map showcasing this exact trend, where the black areas on the map represent all the unmapped, unexplored parts of the ocean. So how can whales help with this? This story takes us to the collection of fin whale vocalizations that made it into news over half a year ago. It begins at Oregon State University, where seismologists were using ocean bottom seismometers to monitor earthquakes. For the seismologists, cetacean calls such as fin whales are often a nuisance because it muffles their measurements. Here are fin whale vocalizations that were picked up on the seismometer. Although often a nuisance for one of the researchers, Nábělek, however, this presented an opportunity. Since fin whale calls can reach up to 189 decibels, they can penetrate deep into the seafloor layers. Correspondingly, when the whale call hits the seafloor, some of these sound waves are converted into seismic waves that travel through the layers of the ocean crust. The seismic waves then bounce off layers at different rates, and that delay in the reflected wave's arrival reveals each layer's thickness. Such, by measuring the time it took for the waves to reflect back, they could estimate the thickness of each crust layer. Why this advancement and discovery is important is that it is opening up a whole new domain of how we can explore the ocean floor through non-invasive measures. Often air guns, such as pictured here, are used to map the ocean floor. They are essentially just loud blasts of air, and they can reach up to 250 decibels and can be heard for miles. Here is what they sound like. These seismic surveys will often travel for months on end. They are used for mapping the seafloor, often to locate and estimate the size of offshore oil and gas reserve. Some seismic blasting surveys will conduct over 1.5 million blasts in the surveying time period. That is roughly the sound intensity of a space shuttle launch every 10 seconds, 24 hours a day, over a 6-month period. One can imagine the devastating effects this would have on ocean ecology. A report issued by Oceana in 1 year said that the impact of seismic blasting could also result in the injury of death of 138,000 whales and dolphins and 13.5 million disturbances in vital behaviors such as mating and feeding. This also severely disrupts sea turtle nesting, increases death of fish eggs and larvae, and has major impacts on fish migration and spawning. The blasts are also known to reduce catch rates of commercial fish, impacting the local economies. Although fin whale vocalizations do not have the potential to replace high-energy broadband air gun signals in ocean crust studies, they may complement passive seismic experiments during deployments of ocean bottom stations. The researchers say this could also be improved by using higher pitch calls from other whales, like sperm whales. As this research is just emerging, there is lots of room for improvement. All in all, this demonstrates that animal vocalizations are not only useful for studying the animals themselves, but also for investigating the environment they inhabit and how they can better help us understand the seafloor in a non-invasive, cost-effective, simple way that would be accepted. In a way, this kind of relates socially to how we've been programmed to explore our world. We don't always need to use human-built approaches to find the answers to some of these problems. Our Earth, especially the ocean, has so many natural tools we can utilize. All we need to do is just look around, or in this case, listen.